Today, we're going to be going over the sine rule, the cosine rule, and the area rule. So here we have just a regular triangle, and we've labeled each angle as capital A, capital B, and capital C. That is very important. The angles are always labeled as capital letters. And I've labeled the opposite side length to the angles as the lowercase letter. What I mean by that is, if you look at capital angle capital A, and you go to the opposite side, I've labeled that length as lowercase a. If you look at capital B angle, go to the opposite side, that side length is labeled as lowercase b. And this applies the same for angle C. The opposite side length is labeled as lowercase c. This is very, very important when we're talking about the sine rule, the cosine rule, and the area rule. Now let's start off with the area rule. We know that the area is equal to half base times height. So let's draw in our perpendicular height. So this is the height. Now, we also know that we can represent h by using the angles and the side lengths. We know that h is equal to c times sine a. H is c times sine a because sine is the opposite over the hypotenuse. So opposite of a is h and the hypotenuse is c. So h over c is equal to sine a. And if I times c to both sides, and this is lowercase c, remember, because it's the side length, you get h is equal to c times sine a. Now, I'm going to substitute this into our area formula. So a is equal to half base times c times sine a. Okay? And this is just half bc sine a. Now, this is true for all triangles. Let me draw another triangle. And show you how that works. Here we have another triangle. Let's label this as C. So this is angle C. This is A. This is B. This is B. This is A. Okay. Again, the area is half base times height. This time the base is A. Now, what is the perpendicular height? The perpendicular height is going to be here, what we label as red. That's our height, H. Now, how can we represent H in terms of angle ABC or side length ABC? We know that H is going to be sine C times the hypotenuse, which is B. So H is equal to B times sine C. Now we can substitute that into the area formula. So area is equal to half base, which is A, times height, which is this, half AB sine C. Now, these two may look different to you, however they get you the same answer. We have to know is that the angle that we are sining is the angle in between the two sides. So here we have A and B, and the angle in between those two is what we have to sine. Same over here. We have C and we have B, and we have to sine the angle in between those two, which is A. And I could just rearrange all the letters and just move them around, and I'll get still half AB sine C. Okay? Now, let's move on to the sine rule. We have our same triangle, and I've also labeled the height. Okay. Now, how do we represent h again? We know that h is sine a times c. H is c sine a. We've already showed this before. However, there's another way of representing h, and we could look at the red triangle. This time, h is also equal to a times sine c, for the exact same reason. The hypotenuse is a, and the angle is c, and the opposite is the height. Now we can equate these two together, and we get c times sine a is equal to a times sine c. If we rearrange this, we get sine a over a is equal to sine c over c. Now, I can also use a different height and make another point. Let's take this height right here. Let's take that height right here. Now, what is this height going to be equal to? This new h, which I've wrote in white, h is equal to a, because a is the hypotenuse, times sine b. If we look at the other side, it is the same as sine a times hypotenuse, which is b. So b times sine a. If we just rotate the triangle around, we can see this much more clearly. And again, equate these two together. We get a times sine b equal to b times sine a. Rearrange, we get sine b over b is equal to sine a over a. Now look, we've got sine a right here over a, and we've got sine a over a right here as well. So we can equate both these equations together again, and we get sine b over b is equal to sine a over a, which is equal to sine c over c. And this is the sine rule. And I can also write the reciprocal. B over sine b is the same as a over sine a, which is the same as c over sine c. Okay? This is also true for all triangles. Let's move on to the cosine rule. And the cosine rule is a little bit more complicated, but again, involves similar concepts, but uses the Pythagoras' theorem as well. So let me draw a triangle again. You've got A, B, C, C, A, B. I'm going to draw in our height. Label that as H. And I'm going to label this piece right here. Let me zoom in a bit. I'm going to label this piece right here as X. And that would mean that this right here is B minus X. Because this entire thing is B. Okay, now that we've got that out of the way, let's use the Pythagoras theorem on certain triangles. Let's first focus on this red triangle I'm drawing in now. So in this triangle, x squared times plus h squared is equal to c squared, because c is the hypotenuse. Now we can focus on the other side, where we know that h squared plus b minus x squared, because remember this is just b minus x, is equal to a squared, because A is the hypotenuse. Now, we can substitute these together, because we rearrange to make h squared the subject, and then we can substitute these in together. So here we have h squared is equal to c squared minus x squared. And here we have h squared is equal to a squared minus b minus x all squared. Now, as I said, we equate these two together. So we have c squared minus x squared is equal to a squared minus b minus x squared. Okay, now let's rearrange this and then we'll expand out the brackets. So this is c squared minus a squared plus b minus x squared is equal to x squared. Now we're going to expand out the brackets. So c squared minus a squared plus b squared plus x squared minus 2bx is equal to x squared. And notice how the x squareds cancel each other out, just like that. And we can add a squared to the other side. So we have c squared plus b squared minus 2bx is equal to a squared. Now, what is the value of x? We look over here. We know that x is equal to c times cos a this time, because cos a is adjacent of our hypotenuse, which is x over c, and we times c to both sides, we get this. So let's substitute that in. We know that x is equal to c times cos a, so a squared is equal to c squared plus b squared minus 2b, I'm going to substitute this in now, 2bc times cos a. And this right here is the cosine rule. And this is true if I also, again, rearranged all the sides. The important part is that the side length that is being initially squared and its corresponding angle, which is the angle opposite it, is the angle that's being cosigned. Okay? Hence why capital A here and lowercase a here. And I can also write b squared is equal to a squared plus c squared minus 2ac times cos b. Okay, I'm just rearranging all the letters around. And if you want, you can have a go by doing that here. Just rearrange all the letters around and you'll get the same thing. And that applies for all of these rules. Okay, now let's go over some of the key topics that you need to understand what I just taught you today. And if you did find this difficult, have a look at some of the videos that I have released or videos that other people have released based on those topics. The first topic is trigonometry. Obviously, you need to understand your trigonometry, understand what cos of an angle is, what sine of an angle is. Now, you also need to know what the area of a triangle is. And specifically for the cosine rule, you also need to understand what the Pythagoras' theorem is. Okay? And know your basic algebra. Thank you very much for watching.